Good morning, students. Today we are going to discuss about the next topic of metals and non-metals. Those are chemical properties of metals and non-metals. Chemical properties. In the last class, we have discussed about the physical properties of metals and non-metals. Today we are going to discuss about the chemical properties. The first chemical property, yes. Yes, today we are going to discuss about the chemical properties of metals. Chemicals. Metals reacts with the oxygen. Metals reacts with the water. Metals reacts with the acids. Metals reacts with the hydrogen. Metals reacts with the chlorine. Metals reacts with the different type of sulfates. Then what is the result? Yes, today we are going to discuss about these all things. Metals reacts with the oxygen. Starts with the metals reacts with the oxygen. Chemical properties of metals. Yes, what happens when metal reacts with oxygen? Reacts with the oxygen, they form oxides of those metals. I repeat, when the metal reacts with the oxygen, they form oxides of those respective metals. For example, when metals reacts with the oxygen, they form oxides of those respective metals. For example, sodium is reacting with the oxygen, magnesium is reacting with the oxygen, potassium is reacting with the oxygen, calcium is reacting with the oxygen. What is the result? Sodium, potassium, calcium, they all form oxides of those respective metals. Sodium will become sodium oxide, calcium will become calcium oxide, potassium will become potassium oxide, magnesium will become magnesium oxide. We start with the potassium and sodium. Sodium, when sodium reacts with the oxygen, okay, sodium is form sodium oxide. What is the formula of sodium oxide? The formula of sodium oxide is Na2O, because the valence, yes, I'll show the valence here. Sodium valency is 1 and oxygen valency is 2. Okay, and this 2 valency, sodium will get this 2 valency. Yes, the formula of sodium oxide is Na2O. Yes, we have to balance this equation because sodium at the left point. We are having two elements at the left part and right part of the chemical reaction. That is, two elements are in the part of reactant, two elements are in the part of product. But that is sodium and oxygen. Yes, sodium, the LHS side is only one, left hand side, right hand side, sodium is oxygen, left hand side is 2, right hand side is 1. We will balance the this oxygen. Yes, we'll make it as 2 here, 2 here, it becomes 2 now here. Now oxygen is 2, but sodium has become 2 to the 4. Right hand side I have to make it as 4. Left hand side 4. S 4Na plus O2 will give 2Na2O. Sodium is reacting with the oxygen to form sodium oxide. Okay. Next we'll go for the second reaction. Potassium reacts with the oxygen. Potassium reacts with the oxygen to form potassium oxide. K plus O2 to form once again the valence of potassium. Valence of potassium is 1, oxygen is 2, and we are getting the result K2O. The formula of potassium oxide is K2O. Okay, once again the same balancing 4K. Yes, next is the third chemical, that is calcium. Calcium reacts with oxygen. Calcium reacts with oxygen to form calcium oxide. Okay, I'll rub this. I rub this point. Calcium reacts with oxygen. Now I'll see that what is the formula of calcium oxide. The formula of calcium oxide. Yes, the valence of calcium is 2, oxygen is 2. Yes, we'll simplify that. 2 simplified as 1, 2 ones are 2 ones are, and the formula is CaO. The formula of calcium oxide is CaO, CaO. Yes, right side, left side oxygen are 2, so right side I'll make it as 2 oxygen. Okay, calcium also 2, 2Ca plus O2 will give 2CaO. Yes, sodium is reacting with the oxygen to form sodium oxide, potassium is reacting with the oxygen to form potassium oxide, and calcium is reacting with the oxygen to form calcium oxide. 4Na plus O2 to we have to balance the equation also. 4K plus O2 to give 2K2O and 2Ca, that is calcium reacting with oxygen. 2Ca plus O2 gives 2CaO. Yes, these all have formed oxides. Here also oxide is there. Here also oxide is there. Okay. We are having, why these three are preferably first? These three elements reacts vigorously with the oxygen. When you take this element, sodium, you take the potassium and keep put it in the atmosphere, immediately it start to react. So only I had taken these elements first as per the reactivity, because these will only make the reactivity series. This which is highly reactive, which is medium reactive, which is least reactive, will be identified here only. Sodium compared to sodium, if you keep the potassium, potassium reacts immediately compared to sodium. These are the changes what we are going to see here. Okay, sodium, potassium, and calcium. Okay, now we'll go for the next elements. Okay, we'll go for the next element. Magnesium reacts with the oxygen. Aluminium reacts with the oxygen. Zinc reacts with the oxygen. Magnesium, aluminium, and zinc. I think so. If you remember it, it was the first reaction what I showed it on the board. The first chapter, chemical reactions and equations. In the chapter, the first reaction as a combination reaction, magnesium reacts with oxygen to form magnesium oxide. I repeat, magnesium oxide reacts with oxygen to form magnesium oxide. And we have even balanced this reaction actually. 2 Mg plus O2, 2 Mg plus O2 to form 2 MgO. 2 Mg plus O2 will form 2 MgO. Yes, but it takes a very long time to heat strongly to get this result. Instantly you will not get result here. You have to heat strongly to get this result. Then only the magnesium will become magnesium oxide. Otherwise you will not get result immediately. Where the potassium, calcium, or especially the sodium and potassium will get instantly result, especially potassium still more, because potassium is a highly reactive element. When you go for these elements, magnesium reacts, you have to heat very strongly to get the magnesium oxide. Even the same for aluminium, same for the zinc. Okay, aluminium. Aluminium reacts with oxygen to form. Aluminium reacts with oxygen to form aluminium oxide. What is the formula of aluminium oxide? Aluminium valency. The valency of aluminium is 3. The valency of oxygen is 2. Yes, we cannot simplify it because one is odd number, one more is even number. So this is 2 comes here and 3 will go this side. The formula of aluminium oxide is Al2O3. Yes, aluminium reacts with oxygen to form aluminium oxide. Al2O3. Aluminium. Now what we have to do it? We have to balance it. Here right side oxygen is 3, left side oxygen is 2. So what to do? We'll make it as LHS and RHS. You'll get the idea exactly. Okay. Two elements are there. That is left hand side, right hand side. One is aluminium, one more is oxygen. Aluminium left hand side, before the reaction we are having one aluminium. Right side we are having two aluminium. Left side we are having two oxygen. Right side we are having three oxygen. Okay. Now aluminium is easy to balance it because 1 and 2 is there. But oxygen, before reaction it is 2, after reaction it is 3. It is 1 is odd. Here I'll take it 2 here. I'll take it 2 here. Okay. 2Al2O3. 2Al2O3. Aluminium has become 2 2s are 4. Right side. Left side is 1. Aluminium rates oxygen. 3 2s are 6. Oxygen has become 6 at the right side. Now, left side oxygen, aluminium. Aluminium 1 is there. 4Al. 4Al. 2 is there. 2 and right side 6 are there. 3 2s are 6. Okay. Now it is balanced. Aluminium reacts with oxygen to form aluminium oxide, and you have to heat strongly to the aluminium to get aluminium oxide. Okay. Yes, it is about the reaction. 2 Mg plus O2 to form 2MgO. Magnesium reacts with oxygen to form magnesium oxide. Aluminium reacts with oxygen to form aluminium oxide. You have to heat strongly to get these results. If these are not the elements, like instantly we'll get the result. Potassium and sodium will get instantly, with calcium also. But magnesium and aluminium, highly impossible. You have to heat strongly to get the result. A very blue flame. The flames are also different types. Yellow flame, blue flame, bluish white flame. Those temperatures vary. If you take about the yellow flame, almost all 300 to 400 degree will be there. And blue flame, what is there in the LPG, will be having around 500 degrees Celsius. Bluish white, 700 degrees Celsius. The temperature varies. Okay, it is also important because last week we did the experiment on the before last week I think so. We did the experiment on iron oxide, iron sulfate. When we heated iron sulfate for 20 minutes, actually we have used the spirit lamp. Instead of spirit lamp, if I use the Bunsen burner, spirit lamp, if you use the Bunsen burner, you could have got the result very fast. Bunsen burner hardly 15 minutes, but spirit lamp 25 minutes. If you use a candle, almost all we will take almost 35 to 40 minutes, because candle will be having brown, red or yellow color. Flame will be there. The color varies, mixed color will be there. But if you take the Bunsen burner, almost or Bunsen burner with the supply of LPG, it will be having the blue color, and the quantity of the flame will also more. So it burns immediately. That is called strong heating. The temperature, even the burning of when the flame is also important here. Okay. Next is zinc reacts with oxygen. Zinc reacts with oxygen to form zinc oxide. The formula of zinc oxide is ZnO, and left side oxygen is 2, right side have to make it as 2, 2, yes, zinc oxide. Even it also needs the strong heating to get the result here. Okay, this is all about the some more elements by where you have to heat strongly for this element to get the oxides. Next is iron. Iron reacts with oxygen. Iron reacts with oxygen. Copper reacts with oxygen. Iron reacts with oxygen. Copper reacts with oxygen. These are the reactions, both are in textbook chapter number 1. Actually, this is a reaction. Iron reacts with oxygen to form iron oxide. Hematite, and this will be a magnetite, Fe3O4. Hematite is Fe2O3. Fe2O3 is there, Fe3O4 is there. This is the Fe3O4 is the reaction which is there for the balancing of equation, if you remember it. Once you go through that textbook part, you are having this reaction as a balance reaction. Why? To balance the chemical reaction, they have balanced this O4. And this reaction, copper reacts with oxygen to form copper oxide. This is for the oxidation reaction. If you open the page number 12, you are having this copper reacts with oxygen to form copper oxide as an oxidation reaction. Yes, these both are from chapter number 1. But why I am showing these elements at the last? Because it takes a very long time to get the result here. For a long time compared to the earlier 3 elements. It may be zinc, aluminium, or magnesium. It was a strong heating. It takes a long time to get the iron oxide. Iron reacts with oxygen to form iron oxide or copper reacts with oxygen to form copper oxide. Very long time it takes to get the result here. Yes, iron reacts with oxygen to form iron oxide, Fe3O4. Yes, I told about this only. Fe3O4. Okay, 3Fe plus 2O2. Fe3 here, Fe3 here, 2 2s are 4, oxygens. Yes, copper reacts with oxygen to form copper oxide. Yes, 2Cu plus O2 will get 2CuO. Yes, this is a, it takes very long time to get the result. Iron reacts with oxygen to form iron oxide, or copper reacts with oxygen to form copper oxide. It takes very long time to get the result. So only these are kept separately. Now I'll give you the reactivity series of all these elements. Reactivity series. Highly reactive, medium reactive, least reactive. Which is highly reactive automatically? Potassium reacts instantly at a spot, spontaneously, vigorously. Next potassium is sodium. Next to sodium is calcium. In that way, I'll write the reactivity series. Which is highly reactive? Automatically it comes potassium. Potassium is highly reactive than sodium. Sodium is highly reactive than calcium. Then calcium is highly reactive than magnesium. I'll show you in that way. Okay. Okay. Reactivity series. Reactivity series. Reactivity series to form the oxides. Reactivity series to form the oxides. The highly reactive element is potassium. Potassium is more reactive compared to sodium. Sodium is more reactive compared to calcium. Calcium is more reactive or more vigorously reactive than magnesium. Magnesium is more reactive than aluminium. Aluminium is more reactive than zinc. Zinc is more reactive than iron. Iron is copper. Okay. Potassium, sodium, calcium, magnesium, aluminum. Here, these three are the elements. Sodium, potassium, and calcium reacts vigorously with the oxygen. You have to heat strongly. You have to heat strongly to get magnesium oxide, aluminum oxide, or zinc oxide. Heat strongly. Heat instantly because it will immediately reacts. Here for the iron and copper, you have to go for a prolonged heating to get iron oxide and copper oxide. Potassium, sodium, calcium reacts at a spot immediately, or the word is vigorously, to form potassium oxide, sodium oxide, or calcium oxide. And if you go for the magnesium, aluminum, and zinc to get aluminum oxide and zinc oxide, you have to heat strongly. You have to go for the last one is iron to form iron oxide or copper to form copper oxide, you have to heat for a very long time. To get copper to copper oxide or iron to iron oxide, iron takes a bit less time compared to copper. It shows that potassium is highly reactive element, sodium is highly reactive, calcium is highly reactive, but copper is least reactive element in this whole group. Copper is least reactive element in the whole group. Potassium is very high reactive, copper is least reactive in this group with the to form oxide. Okay, then yes, this is metals reacts with the oxygen. Okay, next we'll go for the metals reacts with the we are having one more point regarding it, we'll go for it. Okay. Yes, I have shown two elements here, two compounds actually. Oxide of aluminium, oxide of zinc. Aluminium oxide and zinc oxide are called as amphoteric oxides. Aluminium oxide or zinc oxide, aluminum oxide and zinc oxide will those are called as amphoteric oxides because they behave like acid also, base also. S acid also, base also. Acid or base. Amphoteric oxide means these are the oxides which behave like acid also, they behave like base also. For example, it is zinc because already the zinc oxide. I'll show that. What is that? We'll go for the sulfuric acid. Sulfuric acid reacts with the zinc oxide. Sulfuric oxide, sulfuric acid is reacting with the zinc oxide to form zinc sulfate plus water. Acid, base, you know that oxides. I told you this is an exceptional case. Aluminum oxide and zinc oxide. Zinc oxide, salt, water. Acid reacts with base to form salt and water. Here, zinc oxide act as an base. I'll write one more formula. Zinc oxide reacts with the sodium hydroxide. S zinc oxide reacts with sodium hydroxide to form sodium zincate plus water. Yes, we have to balance the equation now. Right. Zinc oxide. Now zinc oxide behave like acid because sodium hydroxide is a base. Yes, see here, sodium oxide, zinc oxide was behaving like a base in the this reaction where sulfuric acid was reacting with the zinc oxide to form zinc sulfate and water. But in this reaction, zinc oxide is behaving like acid to react with the sodium hydroxide to form sodium zincate and water. This is called as amphoteric oxides. Yes, where a oxide of metal like aluminum oxide or zinc oxide, they behave even like acid as well as base. Okay, this is about the amphoteric oxides. Okay, oxides of metals. We'll go for the next part. Yes, next, metals reacts with the water. Metals reacts with the water. What happens when metals reacts with the water? When metal reacts with the water, it forms metallic oxide or hydroxide. I repeat, metal reacts with water to form metallic oxide or metallic hydroxide, and hydrogen gas is liberated. Yes, metallic oxide or hydroxide and hydrogen, it forms when metals reacts with the water, they form it forms they forms metallic oxide or hydroxides, and hydrogen gas is liberated. For example, sodium. Sodium reacts with the water. Sodium reacts with the water to form sodium hydroxide plus hydrogen gas. Okay, 2Na plus 2H2O to get 2NaOH plus H2. Maybe you have observed this reaction earlier in the practicals. In chemistry practicals, you have observed these reactions. In the earlier classes, maybe you have observed this reaction. Sodium in the if they put the sodium in the water, automatically, immediately you get the result. Experiment in the later on classes. Next classes we'll do it. Now, sodium reacts with oxygen, water to form sodium hydroxide and hydrogen. Okay. Now, next is potassium. Potassium reacts with water to form potassium hydroxide, and hydrogen gas is liberated. Maybe you have not seen this potassium, but you have seen the sodium. Sodium and potassium reacts violently and they form exothermic reaction. The water will become hot later on. The chemical, if you take a beaker, in a beaker, draw a diagram here. Take a beaker and if you take a sodium metal and if you put the sodium metal in the water, reacts vigorously. Sodium metal reacts vigorously. Sometimes you have seen the burning of it. Fire also you have seen it. You have seen the fire also in this reaction. If you have observed the reaction, because it depends even on the quantity of water and quantity of sodium also. If you take the sodium, if you cut with the help of knife, and if you put that chemical in the water which has in the beaker, later if you hold the beaker, the lower part of the beaker will become hot. It shows that it is an example of exothermic reaction. And it takes immediately, if you put immediately, start reaction, fastly it is moving inside the water. Very fast is moving it. Which it shows that it reacts violently. Very fast, it may be violent also. Sometimes it may be destruction also because it may burst also. Sometimes the reactions only, these reactions will performed under the supervision of teachers only. Like reaction of sodium with the water or potassium, still more dangerous will be there. Immediate instant reaction will be there. So only these reactions are performed in the presence of teacher only. Okay. Next we'll go for the next part. These two elements will react violently. Okay. Right later. Next, calcium reacts with oxygen. Now, calcium reacts with water now. Calcium reacts with water. Calcium reacts with water to form calcium hydroxide and hydrogen gas. Okay, and this reaction will take in the presence of a normal cold water. Normal water. Here we need the cold water, that is normal or cold water, not too much cold where the temperature is will become 4 or 5 degree. Normal water. Normal water, this reaction takes place. And if you go with the magnesium, magnesium reacts with the water to form magnesium oxide, and hydrogen gas is liberated. If you see it properly, magnesium reacts with water to form magnesium hydroxide and hydrogen. It will not react with the cold water or a normal water. It reacts with the hot water. Yes, it's the difference. Magnesium reacts with the water to form magnesium hydroxide and hydrogen gas to form hot water. Okay, this is all about the reactions. Calcium reacts with water to form calcium hydroxide, reacts with the cold water. Magnesium reacts with the hot water. Now at last we'll go for the next element, that is aluminium. Until now, whatever we have got the result now, those were hydroxides. But I got here metallic oxide also. Calcium, potassium hydroxide. Starting it was sodium hydroxide, later on potassium hydroxide, later on calcium hydroxide, then magnesium hydroxide, These all are the reactions where I got it here: hydroxide, 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 hydroxide. All the metals, metallic hydroxide. But I wrote here metallic oxide also, it is also there. Yes, now we are going to get the oxide. Okay, we'll go for it. Aluminium reacts with, this will be a steam. Yes, this will be a steam, not the, yes, to get aluminium oxide and hydrogen gas. Okay, 3H2O, 4Al, 2Al2 to 3H2O. Okay. Yes, it has become 4Al plus 3H2 will use 2Al2O3 plus 3H2. Now we have got oxide. See here, the oxide is available. Now it is a metallic oxide. Earlier, these all were hydroxide, and it was with the, even apart from that, we are having iron and zinc also, it too with the steam only. Iron reacts with the water to form iron oxide. Yes, we learned that also. Okay, we'll see that once again. We are having the same reaction: 2Fe, 4Fe, and 3H2O will use 2Fe2O3 and 3H2O. Okay, once again we are getting the same reaction because when the valency of aluminum is 3 and here so 3 is there. Valency is same, so we are getting the same result. But once again we are having here oxide. Oxide is available. Fe2O3, aluminium oxide. Here we are getting oxides. Here we are getting the oxides. Copper, silver, gold. Copper, silver, and gold will not react with the water at all. They never react. In any condition, they will not react. With hot water, with cold water, maybe we are storing, I think so, all of us know that we are storing the water in the copper vessel. And the reaction is there. After a long time also there is no reaction. There is no reaction with the water. At any condition there is no reaction at all. We are drinking the same water because no reaction at all. Gold will, will wear the jewelries, gold and silver jewelries, will take bath. After a long time also there is no reaction. No reaction. Copper, silver or gold, they never react with water. So no reaction will take place. Okay, this is about the Next part. Now we'll see the reactivity series of this group. Yes. Now we'll see the reactivity series. A reactivity series is if you go for the reactivity series with the water, potassium is highly reactive compared to sodium. Then sodium is highly reactive with the calcium, highly reactive with the magnesium, highly reactive with the aluminium, iron, and copper. Because potassium and sodium they react vigorously, it will and immediate reaction with sometime it will be explosion. Also, it happens. So only it needs the supervision of teacher whenever we are doing performing the experiment. Sodium or potassium in the presence of with the water. So calcium reacts with the cold water, magnesium reacts with the hot water, aluminum reacts with the aluminum iron reacts with the steam, and copper no reaction at all. So when you go for this reactivity series with the water, reactivity series with the water, reactivity series of metals with water. What happened? Left to right reactivity decreases. Yes, left to right decreases. It is highly reactive element, least reactive or no reactive element. Okay, thank you to all the students. Still we are having some more reactions in our the next class. A reaction of metals with the hydrogen. Yes, chlorine is there, hydrogen is there. The first is acids, acids, chlorine, hydrogen. These are the next reactions in the next class. Okay. Apart from that, acids, chlorine, and hydrogen, we are having them the sulfates and nitrates. Okay, we'll discuss all these topics. Metals reacts with acids, metal reacts with the chlorine, metal reacts with the hydrogen, metal reacts with the sulfate, metal sulfate with the other elements, or metal nitrate with the other elements, other metals. Okay, we'll discuss these all topics in the tomorrow's class. Okay, thank you to one and all.